Assalamualaikum and good day. Okay, we meet again in the second session of lecture intelligence system EEE551. Okay, now today's topic we are going to discuss about expert system. Okay, rule-based expert system. Okay, these are all uh, the outline of the whole discussion in this slide. In the beginning, we are going to introduce you to knowledge, try to define certain terms to be used oftenly in this topic, and then we look at the rules which to represent the knowledge. Okay. In the expert system, rule was used to represent knowledge. And then, what are the main player in the development team? At least we have some idea who are the main player, who are that involved directly in order to develop the expert system. And then we are going to look into structure of the rule base. There are several structure of the rule base. It depends on the engineer and the area which is going to be applied. And then what is the characteristic of the expert system? We are going to differentiate, make a comparison between the expert system and conventional solution kind of method. And then we have two kind of uh, how the rules being interpreted. Okay, there are two technique. The first one is the forward chaining, and the other one is the backward chaining. And then there will be a conflict of resolution where we are going to discuss how the system will resolve the conflict, okay, how it will continue to the results if there is a conflict in the rules. And then we have a summary. Okay, so now we look at the introduction or definition that we will use suddenly in the expert system discussion. Okay, knowledge. Okay, knowledge is most of the words that we are going to use. Okay, knowledge is defined actually a theoretical or practical understanding of a subject or a domain. Okay. So it means that it is when we talk about knowledge in the system, it is a narrow domain. We don't use it as a general domain. It is supposed to be specific to a particular niche area. Okay, knowledge is also some of what is currently down, currently known, currently known. That one we call it knowledge. If you don't know at that particular time, you not consider a knowledge. Because when we develop the system, there are certain knowledge are not appear yet. I mean, it not being listed as a knowledge, but that is the one that you are going to resolve, the one that you are going to search for. Okay, and apparently knowledge is power. So it means that those who possess knowledge, we consider it as an expert. Okay, okay, this is more definition in detail, which relate to the knowledge. Anyone can be considered a domain expert. So domain expert refer to a human. Okay, it can be anyone if he or she has a deep knowledge. Deep knowledge refer back to the knowledge that we just defined it, a specific domain, understanding, theoretical, practical understanding of a specific domain. Okay, knowledge of both fact and rules, and strong practical experience in a particular domain. If you have good experience and you have a deep learning about a specific knowledge, then you are considered as a domain expert. Okay, and the area of domain may be limited. In general, an expert is a skillful person who can do things that other people cannot. Okay, I'll give you an example. In the hospital, there are a doctor. A doctor will not consider it as a expert yet. Okay, even though it knows how, I mean, to deal with a patient. Okay, when a patient come and see and say that, oh, I have a cough. So maybe the doctor can ask to take the temperature, take the blood pressure, take the blood, and check the patient. Okay, that one, it is more in general domain. Okay, you are sick, then you go and see the doctor. That is the ordinary doctor. We don't consider it as an expert domain. Unless if you are feeling pain in the chest, for example, okay, then uh, normally even the ordinary doctor also cannot confirm you. Either you have a heart disease, heart problem, or so on. So you are going to see the cardiologist. Cardiologist is the one that in deep knowledge and experience in the heart problem. So cardiologist, we consider it as a domain expert. It is in a uh, narrow area, narrow subject, niche domain. Okay. So is the one that the skillful person who can do things that other people cannot do. So what does it mean? The ordinary people cannot confirm that you have a disease, what kind of disease, how to treat you. But cardiologists, yes, they have uh, the skill, have the knowledge to identify what kind of heart diseases and how to treat it. It has it can be considered as a domain. Okay. Uh, the human mental process in internal, and it is too complex to represent as an algorithm, even though we have nowadays uh, try to mimic, try to model the brain, how our brain been thinking. That came out the artificial neural network. And you know that because the human brain is too complex, it can consider in general. It's just uh, what we call it is too good to consider to have a knowledge in general. And as you know, even nowadays, as uh, we discussed previously in the quiz, for example, in the assignment quiz I gave you last week, why the artificial intelligence goes to the dark age, because people tend to make it, try to make machine to be like a human thing, like a human resolve, like a human knowledge. Yeah, so it is going to fail. Okay, this is the God creation. Okay, we have to accept it. So human mental process is internal, and it is too complex to represent as in an algorithm. Even a piece of the brain also cannot be replicate into an algorithm, into a machine. However, most experts are capable of expressing their knowledge in the form of rules for solving or problem solving. So this is mean that the human who have the domain expert, they can put they can put it into a knowledge, where knowledge in the expert system will refer to the rules to solve a problem. There are no algorithm, but there are, in terms of rules, where there are a lot of tech in this rule. Also, there are a lot of technique which can be used, and this knowledge can be interpreted to solve a problem. This is what we mean by expert system. Okay, let me see. This is just a simple. Okay, this is simple rules. We look here. This is what the expert system are in the beginning. For example, okay, we have a rule where if the traffic light is green, then the action is go. Okay. If the traffic light is red, then the action is stop. Okay. So in this example, what we can see, okay, the rule is the knowledge is the rule, and the data is either green, red. Okay. This is what we call a rules, which represent the knowledge. Okay, rule as a knowledge representation technique. Okay. In terms of rule, in the AI, in the artificial intelligence, which is most commonly used type of knowledge representation, can be defined as an if-then structure that relates given information or fact in the if part. Okay, you give the information in the if part to some action in the then part. You have information, and then what, based on the information, so what you do, the action. A rule provides some description. If you look back, like a traffic light, okay, a traffic light is red, a traffic light is green. It gives us some description of how to solve a problem. Rules are relatively some description to solve a problem. We refer to the action. In the previous example, if the traffic light is green, so the action is go. Okay, so it will be partial if you have long rules, maybe 100 rules, then it means that some part of rule try to solve certain rules try to solve certain problems. Rules are relatively easy to create and understand. It must be easy and straightforward to understand. Okay. Any rules, when you develop an expert system, any rule consists of two parts. Okay. We have the if part where we call it antecedent or premise or condition, and then we have the then part where we call it as consequent or conclusion or action. Okay, so all the rule must have two parts. These two parts you need to have. Okay, this is the structure, the general structure of the rules. Okay, as I mentioned, you have if the if part we call it antecedent. Okay, and the then part we call it consequent. A rule can have a multiple antecedent. You can have more than one antecedent, which you can join it by a keyword. Okay, either you can join it as and, which is conjunction, or you can join it by or, which means disjunction. Or you can have both of it, a combination of and or. Okay, this is the example. Okay, sorry. Okay, you have if, okay, you have the first antecedent, and then you join it with a keyword and and then you have a second antecedent, and you can have more than it. Okay? You can add more. Or what you can have if the first antecedent, or with the disjunction, or the second antecedent, and so on. Okay, you can have more than one. Okay, this is the structure of the rule. But the key point is you need to have two parts, antecedent, antecedent, and consequent. Where in the antecedent you can have more than one antecedent. Okay? And then you need to have a consequent. Okay, the antecedent of a rule incorporated into two parts where we need antecedent. Okay, in the if part, the antecedent of the rule, the antecedent of the rule, okay, in the if part, incorporated two part. Okay, we call it an object or linguistic object and its value. Okay, where the object and its value are linked by an operator. So what kind of operator that we can have? Okay, where the operator identify the object, identify the object, and assign the value of it. The operator can be such as is, is not, are not, are used to, assign as a symbolic value to a linguistic object. Okay, we can have uh, other form of operator, for example, a mathematical equation as well. Okay, expert system can use mathematical operator. Okay, object and value are linked with operator. Mathematical operator to define an object as numerical and assign it to a numerical value. Okay, by using the operator, then you can assign the object into a certain value, a numerical value. For example, you can use equal to, greater than, less than, and so on. Okay, based on numerical. Okay, this is the example. As we know that this is the object and less than is the operator. Okay, this is the value 18. So in this example, if age of the customer is less than 18 and cash withdrawal is greater than 1,000. So if you look both of it in the antecedent and consequent, they have a value where it is a numerical value. And these values are actually connected to the object by the operator. You see, the operator. Operator is in the first one is less than, the second one is greater than. Okay, we continue again. I take a break for a while. I have something to do just now. Okay, and this is the consequent. The consequent part. After then, a signature of parent is required. So if you look in this example of rule base, if let's say the customer is less than 18 each, each of the customer is less than 18, and then if the customer want to withdraw greater than 1,000, then it requires a signature of a parent. So if you look here, this is one example how you can solve certain problem in the certain particular area. So you can imagine if you have hundred of rules, there are a lot of things, a lot of knowledge, a lot of data can be input to the system. Next, okay, what kind of representation that rules can do? Okay, there are a lot of things that can represent the rules. Okay, first of it is relation. Make a relation. Okay, for example, in this example, if the fuel tank is empty, then the car is dead. If you don't have petrol inside the tank, means that the car cannot work. And then we have rule that represent the recommendation. This is a relation. The first one is relation. Tank, fuel tank empty, that is that. Okay, if you look back here, this is the object, the fuel tank. It is use the operator is relationship. Okay, and then we have the value here empty. Same as then inside the consequent, the is the object, and then we have a value here with the operator is. So when you set up the rules, it is represent a relation. And the next one is the recommendation. Okay, rule also can represent a recommendation. Okay? In this example, you know, if the season is autumn and the sky is cloudy, and also and okay, we have two the what is this, the conjunction, and the sky is cloudy and the forecast is drizzle, then the advice is take an umbrella. So this is a recommendation. And if you look in this example also, all the operator is a what we call it. It's not a numerical operator. Is. Okay. The next one we can have the directive. Okay, directive means give the direction. Recommendation means that it can give some option what you can do. Okay. This is a strong option. Okay. Please take an umbrella. Even though it's not necessary it's going to rain, but it can give you recommendation. Okay. In directive, okay, in this example, if the car is dead and the fuel tank is empty, then the action is to refuel the car. It is quite uh, a simple and straightforward rules, example of rules. Okay. This is us, the user, where to take action to refuel the car at the consequent part. Give the directive. Okay, and then we have a strategy. A strategy. Okay, in the strategy example, if the car is dead, then the action is to check the fuel tank. Check the fuel tank. Then you mention the step 1 is complete. Only until that, and then you make another rule base. If step 1 is complete and the fuel tank is full, okay, after you check and you identify it is full, then the action is to check battery. Then you consider the second rule as a step 2 is complete. This is the strategy. There are a lot of huge, if you use a lot of rules, this is a good kind of representation of rules using the strategy. In order to develop the expert system, it's not necessary to choose only one representation of rules. There are a lot of, you can combine any other representation of rules. And then we have the last one is a heuristic. Okay, normally a heuristic you are going to use the what I mean heuristic is based on the knowledge experience. Okay, for example, if the spill is liquid and we check the spill pH is less than 6 and the spill spirit is spill smell is vinegar, then the spill material is acetic acid. As you know that if less than 7, if I'm not mistaken, in pH, if you have less than 7, it means that it is acid. You consider the liquid as an acid. Okay, this is the representation of if of the rules. We call it a heuristic representation of rules. Okay, so we complete the rules, how the rules can be represented. Now we go to the main player in the development team. In general, we have about 5 members of the expert system development. It is not, some of them are really compulsory and others are not necessary. But we are going to discuss all of it. Okay. So the first one is the domain expert. And the second one is the knowledge engineer. And the third one is the programmer. And the fourth one is the manager and the end user. So, so total actually 6. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, 5. The programmer and project manager and end user. Sometimes all of it we can combine. If you are the one that develop, you can be a knowledge engineer. Okay, this is compulsory. Project manager or programmer is not necessary. Sometimes a knowledge engineer, also a programmer. Also the end user also is not necessary, but it is good to have in order to develop a kind, because we are going to use it. The end user is the one that going to use it. The main thing about later on we discuss into detail each one of it. So the success of their expert system entirely depends on how well the member work together. And it is good to have all the members to work to develop a particular expert system. It is good because each one of them have their purpose and contribution to the expert system development. Okay, this is in we can put in block diagram. Okay, where we have a project manager and then we have a domain expert, knowledge engineer, programmer. Okay, these are all the we call it as a expert system development team, including the end user. Okay. So the domain expert is a knowledgeable and skilled person capable of solving problem in specific area or domain. Okay. This is what we required. Okay. We consider as the most important player in the system development. Okay. This is the person. This person has a greatest expert in a given domain. If you can assess this person, if you can have this person, it means that it is the greatest one. You can do a really good expert system. He has a greatest expertise in the given domain, and this expertise is to be captured in the expert system. So that's why, therefore, the expert must be able to communicate his or her knowledge, okay, how to communicate, how to present your knowledge, be willing to participate in the expert system development, and commit a substantial amount of time to the project. You have to bear in mind that domain expert, they don't know about inferior expert system, how to develop the rule, no. But they are required to give a knowledge in that particular area. So it needs to have a good communication between the domain expert. Okay, the domain expert is the most important player in the expert system development. If you don't have the domain expert, then you are not developing any expert system in that particular area. So we consider the domain expert as the most important player in developing the expert system. And then we have the knowledge engineer. Okay. Knowledge engineer is the one who is capable of designing. Okay. He know about the expert system structure. He is the one that designing, building, and testing an expert system. He or she interview the domain expert. Okay. He is the one that communicate with the domain expert how to get the knowledge from the domain expert. Okay, to find out how a particular problem is solved. Okay, he need to know. Okay, so during communication, he required to ask a question or try to uh, communicate with the expert domain. So the expert domain will give the knowledge to the knowledge engineer. The knowledge engineer establish what reasoning methods an expert use to handle the fact and rules and decide how to represent them in the expert system. Okay. It also need to handle the facts and rules and decide how to represent them in the expert system. It's quite tricky. Means you need to know which one before you come into the conclusion. Okay, which rule need to be in the first one. Okay, there are certain things that really need to knowledge engineer need to know. Okay, knowledge engineer then choose some development software of an expert system shell. Okay, nowadays we have the expert system shell, or look at a programming language for encoding the knowledge. You can also use even the scratch C, but it's quite difficult to start from the scratch to develop an expert system. Nowadays, there are a lot of expert system on shelf which you can choose from. And finally, the knowledge engineer is responsible for testing, revising, and integrating the expert system into the workplace. Okay, he's the one that do all this testing, revising, and integrating. And as we studying this part. Actually, you in this case, you are the one that going to be the knowledge engineer. Okay? And then the programmer. Okay, the programmer is the person responsible for the actual programming, describing the domain knowledge in terms that a computer can understand. Okay, this is in the one that need to code code the programming. The programmer need to have a skill in a symbolic programming such as AI language, as LI lips, prolog, ops, and there are and also some experience in application of different types of expert system shells. Okay. In addition, the programmer should also know the conventional programming language, for example, in C, Pascal, and so on. Nowadays, the knowledge engineer or a programmer can be the same person. It is okay to have the programmer and the knowledge engineer or the same person. But if you are developing a huge expert system, so it is good to have a separate programmer and a knowledge engineer. Since there are sometimes, even though you use the off-shelf expert system program in your particular application, still you need to interface to the user, to the end user. So it needs to do some coding, and you cannot afford to have a knowledge engineer to do all of it. So it is good to have a programmer. Okay. And then we have a project manager where it is considered as a leader of the expert system development, which is responsible to keeping the project on track. Okay, it manage, okay, it advise, it he will make sure that all deliverable and milestone are met, interact with the expert knowledge engineer programmer and user and user. Normally, if you develop your own small application of expert system, also the project manager can be a knowledge engineer and a programmer. So the player means that it's not as important as to be the knowledge engineer. So the compulsory that need to be in the expert system is the expert domain and the knowledge engineer. That one is compulsory. And then we have the end user, okay, where often called just the user, is a person who use the expert system when it is developed. Okay. The user must not only be confident in the expert system performance, but also feel comfortable of using it. It's easy to use. Okay, for example, if you develop an expert system to check heart diseases, okay, you know that uh, uh, ordinary doctor that is the one that going to use it, means not the expert, not the cardiologist. Cardiologists, they are already expert in the field. So it must make sure that the user confident of using it and know how to use it, know how to put data onto the system. So therefore, the design of the user interface of the express system is also vital for the project success, where the end user contribution here can be crucial. Okay, for example, in particular in specific area, as I giving the instruction, as I giving the example for cardiologists for detecting the heart diseases. So means that ordinary person they cannot use the expert system. Uh, Only the end user which know how to put a data into the system that can use the system. Okay, for example, when you are reading the echocardiogram, when you reading the ECG, okay, ordinary person or ordinary people, they don't know how to read it, right? How to measure the wave on the ECG, for example. All doctors, they have the capability because they need to go through, but they don't have the knowledge to identify the diseases, exact diseases. But they know that there is a problem with heart in general. Okay, so that's why the end user contribution also can be considered crucial, but nevertheless, it can be up to the domain expert. Normally, domain expert will do it. So the compulsory player it should be the domain expert and the knowledge engineer. The rest of it can be from these two. Okay, even the end user also can be from the domain expert. Okay, because domain expert also can because it relate to their expertise, so they know how the end user will be interact with the system, what kind of answer that the end user need is known by the domain expert. So that's why only domain expert and knowledge engineer are compulsory to be in the development layer of the expert system. Okay, structure of the rule base. Okay, structure of the rule base. Okay, this is the history back in the early 70s. Newell and Simon from the Carnegie Mellon University proposed a production system model, the foundation of the modern rule-based expert system. Okay, this is the one, the early development of the expert system. The production model is based on the idea that humans solve problems by applying their knowledge, expressed as production rules, to given problem represented by the problem-specific information. Based on this statement that the rule base is the structure of the rule base is okay. The production rules are stored in the long-term memory, and the problem-specific information of the fact in the short-term memory. The production rules are stored in the long-term memory, and the problem-specific information of fact in the short-term memory. Okay, this is the one that being proposed in the early stage. Okay, this is the structure of the production system model. Okay, you have a long term where you have a production rule, and you have a short term, you have a fact, and then you have a reasoning, and then the system make a conclusion. Okay, class. I think I stop here. We are going to continue further uh, in the next lecture. In the next lecture session. Okay. Goodbye and stay safe.